This is the LM317 board here. Okay, that's the IC. Got one ceramic MLCC capacitor on the input side and a 47 UF connected at the output. This one has no capacitor on the adjust pin. The, the regulator come with this tiny aluminum heatsink here, so you really need to replace this if you want to get the most out of this regulator. It's already hooked up there. It's currently set to 24 volts output, and we're gonna test how much current it can deliver into common voltage output: 3.3, 5 volt, 9 volt, 12 volt, 15 and 24 volts. First, we're gonna check what is the ideal voltage drop for the regulator. I have set a 1 ampere output there, and we have a 26 volt input here. Let's turn it on. So the output is about, we have set it to 24 volts, and the output is about 23.58, and we have an input of 26 volts. So with the voltage drop of 2 volts on the regulator, the output is a little bit lacking, so we're gonna increase the output until we get 24 volts on the output. So we have 26.5 volts here and 24 volts output. So good input for the regulator is 26.5 volts, so that's about 2.5 volt voltage drop on the regulator. Now let's see how much current it can do at 24 volts. 1.1 drop already, so almost 0.3 volts drop. Let's increase the voltage to 27. Now the output is increasing, so that's about, we have 3 volts voltage drop on the regulator now. So it's currently dissipating 3 watts. No, that's 1.2 times voltage drop is 3 volts. 1.2, what's that? 3.6 watts. Yes, about 3.6 watts. So the heatsink is here is a little bigger. It's not, the heatsink is not a bit, it's not really hot. So let's continue increasing the current. 1.3, 1.4, 1. Okay, so it shut down at 1.5 amps. So the regulator can do at most around 1.4 amperes. So let's turn off the load if it's gonna reset. Okay, so the output has come back. Okay, see, that's 1.4 amperes, and the output is 23.2, about 0.8 volts lower than 20 volts. Okay, so the output is still decreasing. Looks like 1.4 amperes is not stable. Mm, 1.3 for 1.3 amps. Okay, so that's the output at 24 volts, 1.3 amps, 23.8 volts with a 27 volts input. So 3 volts input output voltage difference. I've set it to 18 volts. I'm gonna include 18 volts in this test. 1 ampere. Okay, so we have 1 ampere load there, 18 volts. The regulation is still pretty good at 18 volts. We still have a 3 volts voltage input output difference. 3 volts voltage drop on the IC. We're gonna check its maximum output current at 18 volts. 1.2, 1.3. Okay, so the same with 24 volts. It's turned off at 1.5 amps. At least the IC has overcurrent protection. On the off. Now we're gonna go to 50. Okay, now it's set to 15 volts. We're gonna set the power supply to 18 volts. Okay, that's about 18 volts. The output is 15.05. Now we're gonna turn. It's already turned on. Turn it on. 0.098, 0.027. What's that? 0.06 voltage difference. Okay, now we're gonna increase the current. 0.3. Okay, this one 15 volts output of at 1.4. Anyway, the output on the output current on the other voltage setting at 1.4, the output voltage is unstable anyway. Ano? It's unstable. Maybe we need to turn it off. Okay, let's set it to oh wow, it's really hot. The IC is really hot. So it's definitely the output is unstable if the IC is heating up. Set it to 12 volts now output. The reason I could not set this exactly to 12 volts is because the Potentiometer is very sensitive, and turning it just a little bit, the voltage drop or increase a lot. So that's the best I could set it. Okay, 12 volts output, 15 volts input, 3 volts voltage drop on the IC, 1 ampere load, 1.2, 1.2, 1.3. So the performance of this is getting worse the lower the output voltage is. Okay, turned off at 1.5. Yeah. Nine volts output, 12 volts input, 0.1, 1.2, 1.3, 5 volts input, 8 volts input, 1 ampere load, 0.2, 1.3, 0.4, turn off at 1.5, 3.3 volts out, 1 ampere load, 6 volts input, sorry, turned on, okay, at 1.2 volt it dropped 0.3 volts, turned off at 1.5. So this regulator is really good only up to 1 amp output. Let's see what will happen if we have a 10 volts voltage difference between output and input. So we have 3.3, so plus 10 volts, we need to have a input of 13.3 volts. And that's about 13.3. 1 ampere load, 1.1, 1.2, 0.3. Okay, that's unstable. Okay, 1.4. So this regulator is only good for up to 1 amp output. Can do a few more. It can do 1.1 or 1.2, but I think for stability it's only good for at 1 ampere. This is the price of the LM317 IC here from DigiKey. 76 cents for one piece. This price is from DigiKey at the price of this regulator from AlieXpress. I guess we're not gonna expect a genuine LM317 IC on this board here. Let's check the temperature of the ice here. It's been running for a bit now with 10 volts voltage difference. Let's check the temperature of the IC. 129, 136. This definitely cannot work. It's not gonna work if the voltage input is 10 volts and with the tiny heatsink. Thank you for watching. Please subscribe, like or dislike. See you next time. This is the board here. It's cost about 49 cents for one piece. With free shipping.